Thank you very much, Derek. Very optimistic. And personally, I'm very happy that I have joined this effort. And I'm very happy that the name of the new vision is Ilion. That is originally a Greek
Yes.
name. Very good. I missed to refer that three points that this webinar is recorded and some parts of it will be used only for dissemination purposes from SolarHub Europe for our project and from ID. And also that, what else? That, okay, for Q&A, I'm trying to follow up with questions. It's better to type your question in the Q&A and more specifically referring to the person that you want to be answered. And I will try to keep track on this and to answer as much as possible. The third thing, it's already forgotten, but I'll give the floor to Dr. Rosie Christodoulaki in order to present us the technology, the pre-design that is focused on solar thermal solution for low temperature heat application for industry and agriculture. Rosie, the floor is yours. We can perfectly see the presentation and you can start.
Thank you very much, Vasiliki. Thank you very much, Derek. Good morning to everyone. Welcome to our first Ignition Accelerator program of the SolarHub Project. Today we will speak about the research and innovation activity, number one, as we number it in the SolarHub Project, with regards to a solar thermal solution for low temperature heat applications. So I will explain the basic things that we have done and we are about to do in order to conclude the commercialization plan of this idea. So let's start. As an overview, the leader of this research and innovation activity is CRES, Solar Thermal Department, and the partners of this activity is UNAM, Center for Solar Energy Research and Applications. Samler is a solar thermal systems manufacturer in Greece. E2, which is the Istanbul Technical University. C, which is the SolarHub Europe, and CERT, the Center for Research and Technology in Greece. Now, in the framework of this activity, we have three reports to make, three big reports. The first one that has been implemented last August is the roadmap for this activity. Is basically the flowchart and the description of what we are going to do. In this December, we will submit, we will develop and submit the technical specifications of this research and innovation activity, which is basically the description of the technical description of this idea. And in March 2026, we will develop the Green Business Plan, which includes all the technical activities, all the research activities, but not only this, economical issues, environmental, social, and as well as a training package will be developed as part of the Green Business Plan, because we would like to support our ecosystems and to promote this idea and to facilitate the market entrance. So that's why we will develop a green business plan for this. So what is the research objective? In a few words, is a solar thermal system for low temperature heat applications. It is comprised of 4 pylons. The first one is the heart of the system, is the solar thermal collector, which will be developed by CRES, Samler, E2 and C. You can see the geographical context of this activity. We have some joint activities and very strong collaboration between countries. So we have international collaboration in all pylons. The solar thermal collector will be developed either in TRL4 or TRL5. However, we target at the validation of the technology, either in relevant environment or in a lab. The second pylon is the heat storage system, which is needed for a solar thermal system. And it will be developed jointly by CERT and GUNAM. So here again, we have very strong collaboration between Greece and Turkey. And it will be developed in TRL3 as an experimental proof of concept. The third pylon consists of the system control, which will be developed by Samler and C, along with an external university, a German university, and it will be developed in TRL2 as a concept formulated technology. The fourth pylon is a dimensioning and levelized cost of heat tool. It's basically a tool that will dimension the whole system, this new system, and not only it will provide the sizing of the basic components, but also it will elaborate, it will calculate the levelized cost of heat for its application. It will be developed by GUNAM in collaboration with CRES in TRL2 as a formulation of a technology concept. The key exploitable result is the construction and the certification of a solar thermal collector. So at the end of this research activity, the main key exploitable result, it will be the solar thermal collector itself. It will be constructed and certified, so it will be ready to enter the market. Now let's see in more details the concept. You see here the 4 pylons. So regarding the first one, the solar thermal collector, we aim at designing and constructing the collector. As a specifications, the basic specifications will be the heat production around from 80 to 120 degrees Celsius. So it will be a flat plate, basically a flat plate collector, not any advanced concentrating technology. It will aim at industrial and agricultural applications, and some specific characteristics, technical characteristics. It aims at a high efficiency, at a low heat capacity, at high reliability due to the selection of materials, modularity issues, because we want to be applied at large scale systems, and it will be in line with logistic and transportation limitations. Regarding the control system, the aim is to design the concept of a control system that will have the following characteristics. It will ensure optimal system efficiency. It will aim at reducing the operational costs of a solar thermal system. It will provide autonomous and self-optimizing energy generation, and will also plan of predictive maintenance actions. So these are the targets for the control system. Regarding, regarding the thermal energy storage tank, the tank will be designed and experimentally validated in a lab environment with the main technical characteristics of a sensible heat storage and use of low cost and abundant ceramic materials. So its main characteristics will be low cost, and it will exploit sensible heat storage. And the final pillar, which is the tool, the calculation tool, The aim is to size the basic components of a solar thermal systems, which is the solar thermal collectors field and the storage tank, and it will calculate the levelized cost of heat in terms of euros per kilowatt hour. Of course, it should be user-friendly because we want this tool to support the market entrance of our research and innovation activity. And we want to facilitate the potential customers of this technology, of this product, and as well as the end users of this technology. So the tool is very important for the green business plan. Now, these are some photos of the solar thermal collector, the pre-prototypes that have been already constructed. And this is the flowchart of our methodology on how we will approach a new design, a new product of a solar thermal collector. First of all, we identify the problems in existing products. After identifying the existing problems, then we aim to optimize the design of a solar thermal collector, especially for industrial and agricultural applications. So we develop the new design. Then we analyze it and we simulate it in theory. We calculate the energy performance, the theoretical energy performance of this new design. So we transfer this design into a software that can theoretically calculate this annual energy performance. And of course, we do some computational fluid dynamics, which are targeted analysis of the thermophysical characteristics of the collector. Then we constructed 2 pre-prototypes. Up to now, we have constructed 2 pre-prototypes. Why 2? Well, the first one is because we wanted to test this new design. We constructed the first pre-prototype and we saw that problems still existed. So we constructed the second pre-prototype, and now we are in the process of constructing the third pre-prototype, and we hope that it will be the final prototype. So after the construction of pre-prototypes, we identified problems that still existed, and we proceed to optimization of these designs. Then, and this is the point that we are now, the construction of the final prototype that we hope that has overcome all the previous problems of the designs, and it will proceed for testing and performance evaluation. If this final prototype passes all tests and has a performance that is within our requirements, then it will be it will proceed to certification. After the solar collector, the new developed solar collector is certified, then it will proceed to to enter the market. Now, regarding the thermal energy storage tank, you see the Autogunam's fluidized test bed setup here. Here it will be the laboratory, basically, where the materials will be tested. So in order to design a new thermal energy storage tank, we again identify problems in existing storage systems, and we try to find solutions to these problems. So we developed a new design, and not only a new design, but also we tried to select other materials out of the box that could serve as heat storage materials and have the the advantage of being low cost. So we have already, and we are in the third step to the physical-chemical characterization of those materials. So we have selected 3 potential materials that are low cost, abundant, and these materials will be tested against their thermal properties, aging, and structural integrity in order for them to be used inside thermal energy storage tanks. Then we will proceed with the theoretical analysis and further simulations, and then we will evaluate experimentally their performance. Regarding the system control, the first step is desktop research in existing controllers and analysis of potential improvements and room for improvements. Then we will design the tool and we will we will elaborate the flowchart of the calculations, and then the estimation of the potential cost effectiveness and integration concepts to the system, to the solar thermal systems will be investigated. So these are the steps for studying a new system control. Now, last but not least, the levelized cost of heat and dimensioning tool. You can see the structure of the calculations in this picture developed by Otto Gunnar. So first of all, we think of a flowchart of calculations, how the calculations will flow. And then we have to find databases and libraries that will be served as input data. We will use input data. For example, we use the database of SolarKeymark in order to utilize the databases of solar thermal collectors. We also connected this tool with the PEVET GIS, which is in order to get meteorological data. We also utilize a pool of costs in order to use it as insert data, input data to our tool in order to provide this levelized cost of heat. So the second step was to develop and search for databases and libraries that could be used as inputs to this tool. Then the third step is to verify the calculations because this calculation should be verified and compared against the logic. And then after verification, this is a loop. The verification and optimization is a loop. So the next step is to optimize the tool environment and to optimize the tool calculations and then the tool environment. And then the release of the tool along with the final product. This will be done simultaneously because the tool supports the market entrance of the product. So the final step is the release of the tool. Well, here are the challenges of this research and innovation activity. I could have more slides in this, but I selected the most important ones. So the collector, a challenge is the manufacturing process itself. When we design a new concept of a solar thermal collector, we have to take into consideration the real manufacturing conditions and the real assembly challenges that this new design will face. So transferring the theory and the studies into practice is a challenge itself. Another challenge is the theoretical simulations and the CFD simulations that allow to optimize the design. These simulations are done with fine mesh. And these fine meshing elements are very time consuming. So we have to find a balance between time and effectiveness in order to design this collector with an optimal way, but not to spend 3 years of our time for the design, because this is not efficient. So we have to find a balance between time and effectiveness. And this is also a challenge. Now, regarding the control, we have to ensure the optimal system efficiency, and we have to prevent the system failure, and we have to find some smart ways to do this. Last but not least, the system, in system level, we have to successfully integrate all these 3 components, the collector, the tank, and the control, into a unique system that will efficiently provide renewable heat to agricultural and industrial applications. And the collaborative opportunities that we seek in this research and innovation activity lies in the market entrance of the collector, in the further development of the smart control, in the installation and maintenance process and requirements, and any other idea that you as audience can think of. Thank you for your attention. Here you can find some contact information, and I'm available for any questions you have. Thank you very much.
Very good. Thank you very much.